Hi there. We are going to do a lesson on multiplying and factoring polynomials. So, our two learning targets are 1, to multiply monomials and polynomials, and 2, to factor a monomial from a polynomial. Okay. What we'd like to do first is learning target number 1. So what I'd like to do is review this thing called the distributive property. If you recall, when you first learned the distributive property, you probably learned about multiplying the outside thing to all the inside things, forming these nice little waves, okay? Alright, I can't talk like that anymore. Woo! That was a fun little voice I made there. But just imagine if I did 10, 15 minutes of that. Woo! Can't do it. But we are going to review the distributive property because what we're going to do in this first goal is actually very similar to it. It's just making it a little bit longer, maybe. So this would be 2 times x plus, and then 2 times 4, which would be 2x plus 8. All right, so if you know how to do the distributive property, you know how to multiply a monomial by a polynomial. So remember, a monomial is just one term, or it's an expression that just has one term, and a polynomial has multiple terms. So, a couple of tips here. You can use the distributive property to multiply the monomial by the polynomial, but just remember the rules of exponents if you're multiplying exponents. So, here's the first example. This is a short, it almost looks just like what we did. There just happens to be a variable on the outside as well. So we're still going to do the distributive property. So we have 2x times 3x and minus, and then 2x times 2. So 2x times 3x, you may recall we can rearrange it and put the numbers in front. So we do 2 times 3, which would be 6, and then x times x, which is x squared. We have our minus sign, and we do the same thing with this one. We can just multiply the 2 by the 2, which would give 4, and it'd be 4x. All right, so this would be your expanded answer. All right, and we're actually going to go backwards. In our second half, our second goal is going to be going backwards, taking something like this, and then going to do that. All right, so backwards. But for right now, we're just multiplying. Here's the next one. All right, we have negative x squared on the outside multiplied by the polynomial 9x to the 4th power minus 2x cubed plus 7. So we're still doing the distributive property, just to 3 things. All right, so we'd have negative x squared times 9x to the 4th power. If you want to write it as negative 1, you can. I would suggest that. Minus, we'll do negative 1x squared again times 2x to the 3rd power plus negative x squared times 7. All right. First of all, I see right here this is going to be plus a negative. That's going to be minus negative is going to be plus. All right. But now going to this section here, negative 1 x squared times 9 x to the 4th. So if we rewrite it, it's negative 1 times 9, and then x squared times x to the 4th power. Negative 1 times 9, we have negative 9. And then this would be x to the 6th power, because we would add those exponents there to simplify it. All right, then we have plus. Now right here we have, really we have the 1 times the 2. That should be easy, so we have 2 in front. And then we have x to the 2nd power times x to the 3rd power, and that would make x to the 5th power. All right, then we have our plus again. But this time it's going to be negative, we'll put a negative 1 in front of it, negative 1 times 7. And then we have just x squared after it. So we'd have negative 7x squared. All right? Nothing else can be combined. That is the simplified or the expanded version of this multiplication here. So, it is your turn. What is the simpler form of this? So why don't you take a second and try to solve this on one on your own. Pause it, and then unpause it so that you can see how we did. All right, so when you go ahead and distribute that outside, that 5n to all the parts, um, you end up getting this result. Now, just as a reminder, when you have an 5n in front, that's like 5n to the first power. So you can put a 1 here so that when you're multiplying the exponents with the same bases, you know to add those exponents, that 1 in there. All right, so you get 15n to the fourth power minus 5n to the third power plus 40n. All right. Um, This is going to be a review, but this is going to help us with our second goal, factoring. So remember, factors are things that are numbers that are multiplied to get to the final result. So if we're doing prime factorization, we're trying to pull out the prime numbers. So let's start with 20. What two numbers, and hopefully one of them is a prime. This is how you do the prime factorization tree. Hopefully one of them is prime. Um, well, let's do 2. 2 is a prime number, 2 times 10. Okay? So 2 is a prime number, we're going to stick with that. Now let's break down 10. We can do 2 times 5. And those are both prime numbers as well. So the prime factorization for 20 would be 2 times 2 times 5. All right? Now, when we're trying to find the greatest common factor of monomials, we're going to do a similar thing. We're going to first find the prime factors of each term, or just the factors. We're going to find which prime factors are in common between the different monomials, and then we're going to multiply those common factors together to find the greatest common factor. So here's an example. I have three different terms here. We're going to break each one down. So we have 12 x to the third power y. We have 20 x to the second power y to the second power. And we have 28 x cubed y. So let's break each of these down. First one, prime factors of 12, we do have 2 times 2 times 3, I believe. And then we have times x times x times x times y. This one we could do 2 times 2 times 5. We actually just did that. Times x times x times y times y. And then 28 we could do 2 times 2 times 7. Those are all prime factors. Times x times x times x times y. So now we just need to find what's in common. So we have a 2, we have another 2, we have an x, we have an x, and we have one y in common for all of them. So let's put those all together. The greatest common factor of these monomials would be whatever 2 times 2 times x times y is, which would be 4x squared y. That's the greatest common factor, the greatest number that you could divide each of those by evenly. All right, so why don't you try this one on your own? I'm going to give you 3 terms of your own. Find the greatest common factor between those. All right, and why don't you pause it now, and then try it, and then unpause it and see how you did. All right, so the greatest common factor of those 3 would be 3x. And if you look at the 3, you can pull 3 out of all 3 of them. That's the biggest number, and the most x's you could pull out of each of them would be 1. So 3x would be your greatest common factor. Now we're going to use that skill that we just found to factor out a monomial. So it's like we talked about just before um, how it's almost like the distributive property backwards. We're going to go backwards and we're going to pull out a number and put that in front. So here's our steps, our basic steps for factoring out a monomial from a polynomial. Factor each term and find the greatest common factor. Then factor that greatest common factor out of each term and rewrite it with that greatest common factor in the front and the remaining parts in the parentheses. So let's see how that works. Here's an example right now for you. This actually was given, so this was the example. It was 4x to the fifth power minus 24x cubed plus 8x. And you're asked to factor it. So factoring it, you're trying to find the greatest common factor in all three parts. So if you look at all three parts, we have 4x to the fifth power, we have 24x to the third power, and 8x. We can do the prime factorization. And if you look at it, you can find a 2 in common, another 2 in common, and an x in common. So that would be 2 times 2 times x, which would be 4x. So the greatest common factor is 4x. So pull that out of each of them. So when you take this first part, when you pull it out of here, when you pull out 4x, all you're left with is 1x to the fourth power, or right here. When you pull it out of the second term, you'd have 6x to the second power, or minus 6x to the second power. And when you pull it out of the third one, we'd have 2. That's it. All right? So when you pull that out of each one, you put that in front of the parentheses, like we have right here, and the rest that's remaining, which we just found, x to the fourth minus 6x squared plus 2 is what's left inside of the parentheses. And your way to check that would be, all right, well, let's do the distributive property. If we want to just do the distributive property, would it end up back at what you started with? If it does, then you definitely did it right. So the factored form of this polynomial would be 4x times x to the fourth power minus 6x squared plus 2. All right, so if you want to try this on your own, I'm definitely going to go through this one with you. So if you want to pause it now and try it, otherwise I'm going to start going through it right now. So if we look at each term, so you can write these over here if you want to find, I think I can tell right now you can pull out 3 from each of them, and you can pull out x squared from each of them. So I'm going to say the greatest common factor is 3x squared. But I'm going to check just to make sure. So 9x to the 6th power would be 3 times x times x times x times... I'm running out of room. Let's pull this down. I'll erase it in a bit. So times x times x times x times x times x. Oops, too many x's. Sorry. Alright, now the next term was 15x to the fourth power. I don't know why things keep moving on me. So I'd have 3 times 5 times x times x times x times x. And then the last term I'd have 12x squared would be 2 times 2 times 3 times x times x. So what's in common there? We have a 3 in each one. And I can find 2 x's in common between each one. So that's where I got the 3x squared. So I was right to look at it at the beginning, just seeing what you can pull out of each one, what would be in common, all right? So that's our greatest common factor. So that's what's going to be on the outside. So if you do this, if you rewrite this, this would be 3x squared times what's left would be 3x to the fourth power, because that would make 9x to the sixth power, plus 3x squared, and we'd have 5x squared left in there. And then we have plus 3x squared times 4. That'd be it. Okay? So these are the parts that are left. Meaning, when you pull out the 3x squared and put it out in front, that's what's left. We have 3x to the fourth power plus 5x squared plus 4. And that is the factored version of this polynomial. All right? So I do have a real world example for when you could use this. It deals with area of a helicopter pad, and really anytime you have area or volume or a lot of geometry is actually real world, especially if you're in the field of mathematics, if you're in the field of architecture, if you're in the field of engineering, you will use things like this, and you have to use this logic and this reasoning. I'm not going to go through this step by step, but it is in the textbook if you want to use it. Otherwise, you can pause it here and take a look at it. It kind of breaks down how you're finding the area of a certain part of that helicopter pad. But I'm going to leave you with one closing question. Explain how to find the greatest common factor of two numbers to someone who doesn't know how to do it. So we just talked about it. All right? How do you find the greatest common factor of two numbers who has no clue how to do it? Think that one through. If you're able to do that one, and if you're able to do these two goals, which I hope you are, then you've met our learning targets for today. To multiply monomials and polynomials, and then to factor a monomial from a polynomial. All right. Have a great rest of your day. That's multiplying and factoring polynomials.